Okay guys, here's the last part of our review video. There's a couple typos, I just fixed them, but it says a repairman leans the top of an 8-foot ladder against the top of a stone wall. So really quick, this video is just going to be the last 4 word problems. So here's my wall. It's a stone wall, so I'll make it a stone wall. Picture's a lot better in my other one. So there's my stone wall. There's an 8-foot ladder leaned against the top of it. So that's going to be my ladder. We know that this is 8 feet. And we know that the base of the ladder is 5.5 feet away from the wall. How tall is the wall? So how tall is this? Round your answer to the nearest tenth of a foot. Well, notice I have the length of 2 sides. I need to solve for the length of another side, so I'm going to use the Pythagorean theorem. The Pythagorean theorem says a squared plus b squared equals c squared. Remember, the hypotenuse has to be on the side by itself. That's going to be c. So I'm going to have x squared plus 5.5 squared equals 8 squared. 5.5 squared is 30.25. 8 squared is 64. If I subtract 30.25 onto the other side, I get 33.75. And then I take the square root of both sides. And when I take the square root, I get 5.0, but we're leaving it to the nearest tenth. So 5.8 feet is the height of the wall. Okay, so drawing the picture is the important part to get you started. So let's keep going. Here's the next page. Word problems are hard for drawing the pictures, but once you can draw the picture, typically solving's not too bad. So let's take a look. It says a square tablecloth has a line of embroidered flowers along the diagonal. It doesn't matter if you don't know what embroidered means. It really just means fancy stitching, like sewing. But even if you didn't know, it wouldn't matter. All we need to know is there's a square tablecloth, and there's flowers on the diagonal. So here's my flowers. Okay. The tablecloth, remember a square tablecloth, the tablecloth is 48 inches on each side. How long is the embroidered line? Well, remember, even if you didn't know what this means, we know that the embroidered thing is along the diagonal. So we're asking, how long is this? Well, if this is a square, we know that these are all right angles. Wait a minute, that's a Pythagorean theorem problem. I have 2 sides. I'm solving for a third side. So I'm going to have 48 squared plus 48 squared equals x squared. Ooh, that's huge. So I have to take the square root of both sides. And I get 67.88, but it says round to the nearest inch. So I'm going to just call it 68 inches. Now there's actually a second way to do this. Just that these 2 sides are exactly the same. We know it's an isosceles triangle. And the only isosceles right triangle is a 45, 45, 90. So your other option is to say, okay, my leg is 48. To get to the hypotenuse, I multiply by root 2. And if you were to type that into your calculator, you would have gotten the exact same things. So that's your second way to do it. Okay, number 42. A person is standing 40 feet from a flagpole. So here's my person. They're standing 40 feet from a flagpole and can see the top of the pole with an angle of elevation of 35 degrees. Remember, angle of elevation and angle of depression means if I'm looking straight, how much do I either have to look up or down? Since this is an angle of elevation, I'm looking up 35 degrees. The person's eye level is 4 feet off the ground, so this is going to also be 4 feet. What is the height of the flagpole to the nearest foot? So let's use this right triangle. We know we're 40 feet away. I forgot to put that on here. So let's solve for x. So here's my angle, opposite side. This is my adjacent side. So I'm going to use tangent. To get x by itself, I have to multiply by 40 on both sides, because 40, dividing by 40 and multiplying, they undo each other. They're inverse operations. So I get x equals 40 times tangent of 35. So x is approximately 28. It says round to the nearest foot. Yeah, so this is about 28 feet. But the problem isn't asking for x. It wants the whole height of the flagpole. Notice, because this person's looking straight, the height of their body isn't being counted into for this right triangle right here that we have, right? So here's my right triangle. That's what I'm seeing, it's helpful. Right? We solve for this, but we want the whole height of the flagpole. The whole height of the flagpole goes down to here, and so we have to add that 4 feet on. So when I add that 4 feet on, I get that the height is actually 32 feet. Okay, last one. An airplane is flying, there's my airplane, at an angle of 22 degrees. So here is my airplane, it's flying. So at an average angle of 22 degrees at which the airplane must descend for landing. So this is a key word here. It's descending for landing. So my plane is actually going to fly like this until it gets to the airport. So if he's looking straight and then he's going, oh, sorry guys. He's looking down, or he's flying down with a 22 degree angle. Okay. The airport is 12,000 feet away. So I consider that to be the 12,000 feet, but some people say that when they draw the right triangle, some people put the 12,000 here. That's like the distance over land. I don't care which one you do. If you had done this on a test, I would have given you credit if it was here or here, but I'm going to do it for this one. It says find the altitude. Altitude means how high off the ground is the plane, round to the nearest foot. Well, remember, if I have angle of depression, there's two options. I can say, wait, there's alternate interior angles, because these are both horizontals, which means this is 22. Or you could say, well, wait a minute, this is a horizontal, this is a vertical, these have to add up to 90, but I'm going to use that 22. So here's my trig, here's O, A, H. So sine of 22 is equal to my opposite side over my hypotenuse. To get x by itself, I have to multiply both sides by 12,000. When I do that, I get 4495, and it's rounded to the nearest foot, so that's it. So that's how high off the ground the plane is. Okay, so I hope that was helpful, guys. If you need to go back and look at the videos again, you can, but remember the key to all these problems, it doesn't have work shown, but all the keys are on Blackboard, okay?